Hello and welcome everyone. Today is lecture 5 in which we will discuss about different examples of disaccharides. So let's start today's lecture. First of all, what is disaccharide? We already discussed it in previous lectures. Disaccharides are those carbohydrates which are formed when two monosaccharides joined covalently by an O-glycosidic bond formed between two monosaccharides with the release of water. So when two monosaccharides join together and form a disaccharides by a glycosidic bond formed between two monosaccharides, and also in this reaction water is released. We already discussed this in the lecture about biomolecules, because it is the type of reaction which is known as condensation reaction. So in this reaction water is released. As a result of this condensation reaction, different types of glycosidic linkages are formed, which is found in different types of disaccharides. This is alpha 1, 2, alpha 1, 4, and alpha 1, 1, etc. are the type of glycosidic linkages which are formed when disaccharides are formed. Some important examples of disaccharides are as follows. So we will discuss about some of the important disaccharides. First one is sucrose. Sucrose is also known as cane sugar. Its formula is C12H22O11. The word sucrose comes from French word sucre, which means sugar. It is a disaccharide formed from glucose and fructose. So when glucose and fructose combine, it makes sucrose. And a glycosidic linkage, a bond or linkage is formed between the OH group on anomeric carbon of alpha D-glucose and the OH group on anomeric carbon of beta fructose, and it results in alpha 1,2 linkage. So in sucrose, the glycosidic linkage is formed between the OH group on anomeric carbon of alpha D-glucose. We know that glucose and fructose when combined make sucrose. And the OH group on anomeric carbon of beta D-fructose, and results in one alpha 1,2 linkage. Sucrose is also known as table sugar, and we use it in daily routine life, and it is commonly extracted from sugar cane or sugar beets. Sucrose is found in all photosynthetic plants, so it is very important property. Also, sucrose is a non-reducing sugar. We discussed the non-reducing sugar in previous lecture. Because sucrose is non-reducing, because it has no free anomeric carbon atom, because the anomeric carbons of both monosaccharides are used to form a glycosidic bond while forming sucrose. So it have no free anomeric carbon, so sucrose is a non-reducing sugar. Here in figure 1, you can see alpha D-glucose and beta D-fructose combine in a condensation reaction, and as a result, the H2O is released from in this process. Here, a reaction between the H group and the OH group occurs with the release of water. This H group is present at carbon number 1 of alpha D-glucose, and this OH group is present at carbon number 2 of beta D-fructose. So as a result, a glycosidic linkage is formed between carbon 1 and carbon 2 of D-glucose and D-fructose. So you can see here sucrose molecule is formed, and the linkage is alpha 1,2 linkage, because the glucose involved in the formation of sucrose is in alpha orientation, because the OH present at carbon 1 is on the lower side, so it is in alpha orientation, and the linkage is between the carbon 1 and carbon 2 of D-glucose and D-fructose. So the linkage formed in sucrose is alpha 1,2 linkage. So this is all about sucrose. The next important example of disaccharides which we will discuss is maltose. Maltose is also known as malt sugar. Maltose is a type of disaccharides which contains two D-glucose molecules which are joined by a glycosidic linkage between carbon 1 of one glucose molecule and carbon 4 of the other glucose molecules, and it results in alpha 1,4 linkage or bond. So the linkage, the glycosidic linkage which occurs in maltose is alpha 1,4 linkage. Maltose is a reducing sugar as it has a free anomeric carbon 1 residue on the right side of the second sugar. So maltose contains two sugar known as glucose, and one glucose has a free anomeric carbon 1. So maltose act as a reducing sugar. Next is the nature of the glycosidic linkage in maltose is alpha type. It will be alpha linkage, while the glucose molecular residue with the free anomeric carbon is capable of existing in alpha and beta state. So the second glucose residue or molecule is independent, and it can exist both in alpha and beta states. Maltose is less sweet than fructose and sucrose and the basic molecule of starch. Beta amylase cleaves starch into maltose units. This is an important reaction. And the production of maltose from germinating cereals, for example, barley, very important, is an important part of brewing process. Brewing is the production of beer. So maltose is produced from germinating cereals. Most important cereal is barley, and this is the most important part of brewing processes, production of beer commercially. In humans, maltose is broken down by maltases enzymes, yielding two glucose molecules, which can either be broken down to provide energy or can be stored as glycogen and used in future energy requirement. So maltose in human is broken down by the enzymes maltase, and these two glucose further can be broken down to use as energy source or can be stored as in the form of glycogen. This is figure B, in which the formation of maltose is given. We already discussed that maltose is formed between two D-glucose. This is glucose 1, this is glucose 2. This glucose 1 is in alpha form because the OH is on the lower side. So the bond is formed between, a reaction occurs between H and OH group, which results in the release of water molecules, and a bond is formed between carbon 1 of one glucose molecule and carbon 4 of other glucose molecule. So this is a glycosidic bond which is formed between two glucose molecule, and it is results in the formation of maltose. So the nature of linkage is alpha 1,4 glycosidic linkage or bond, because the glucose here, the first glucose is in alpha orientation because the OH group, its U1 is present on the lower side, and the bond is formed between carbon 1 and carbon 4 of two glucose molecules. So it is known as alpha 1,4 glycosidic bond. So this is all about maltose. Next is trehalose. Trehalose is another important disaccharides. Trehalose comes from a Turkish word trihela, which means a sugar derived from insect cocoon. It is also known as mycose or tremalose because it is found in fungi. Trehalose is a disaccharide formed by an alpha 1,1 glycosidic bond or linkage between two alpha glucose units. So trehalose is also formed between two glucose molecules, but the difference is that in trehalose, the glycosidic linkage is alpha 1,1 glycosidic linkage. This is a very unique linkage, and this kind of bonding or linkage makes trehalose very resistant to acid hydrolysis. So it is very resistant disaccharide molecules. Bacteria, fungi, plants, and invertebrates, some insects, animals synthesize it as a source of energy to survive freezing and lack of water. Also, trehalose is a non-reducing sugar because trehalose have no free anomeric carbon. Also, trehalose is the major energy storage molecule used by insects for flights. So those insects which fly can use trehalose as a major energy store molecule. The possible reason for this is that the glycosidic linkage of trehalose is when broken down by the insect trehalase enzyme, it releases two glucose molecules which can provide the rapid energy required by the insect for flight. So it is very important for insects which use it during flight. This is figure C. You can see here two glucose molecules combine to form trehalose. This is glucose 1, this is glucose 2, and the reaction occurs between C1 of one glucose and C1 of the other glucose, and it results into alpha 1,1 linkage because the OH group is the OH group present at C1 is on the lower side, so this is the linkage is alpha linkage. So this is trehalose, which is formed between because the combining of two glucose molecule and results into alpha 1,1 linkage. This is all about trehalose. Next one, the last one of disaccharide is cellobiose. It is very important. Cellobiose is a white crystalline water-soluble disaccharides made up of two molecules of glucose joined by β-D-fructose glycosidic linkage. So cellobiose is also a disaccharide which have two glucose molecules, but the linkage is β-D-fructose glycosidic linkage. Cellobiose is similar to maltose, as we know in terms of saccharides component, because both maltose and cellobiose contains two glucose molecules, but maltose has alpha-1,4 glycosidic linkage and cellobiose has beta-1,4 glycosidic linkage. So the difference is in between the glycosidic linkage, because in maltose the glycosidic linkage is alpha-1,4 and in cellobiose the glycosidic linkage is beta-1,4 glycosidic linkage. Cellobiose is a reducing sugar and can be obtained by the enzymatic breakdown of cellulose and cellulose-rich materials such as cotton, paper, etc. It is a reducing sugar because it contains a free anomeric carbon atom, and also it is formed by the enzymatic breakdown of cellulose and those materials or components which are cellulosic in nature, for example, cotton and paper. This is figure D. Here you can see the formation of cellobiose is given. These are two glucose molecules. This is glucose 1, this is glucose 2, and the linkage is beta-1,4. You can see this is carbon 1 of one glucose, and you can see it is in beta form because the OH group is present on the upper side here, and the bond is formed between C1 and C4 of two sugars. So it is beta-1,4 glycosidic linkage. So this is all about different types of disaccharides. Thank you for watching. See you next time.